Hello, this is Mr. Stansbury. I'm going to take you through the notes on areas of rhombuses and trapezoids. At the end of this, you should be able to say, I can solve problems using the areas of rhombuses, trapezoids, and composite figures. Okay, so we're going to just get straight into some problems to help us figure out this concept here. Find the area of the rhombus. So this rhombus here, really if you take this here, we've got 5, 5, 5, and 5. That's what makes a rhombus. It's a quadrilateral with all the sides are the same, but not all, like the angles are not all right angles. Otherwise, it would just be a square. So what we can do is really, if you look at just this part right here, ignoring this over here, this makes an isosceles triangle. I'm just going to kind of redraw it here, sitting straight up, so we can get a little bit different perspective on it. So this is 5, and this is 6, right? So what we can do, just like we've been doing in previous examples here, is we can take this isosceles triangle and cut it in half here. So this would be 3, and then that's going to be the height, right? So if we find that height, then we can find the area of this whole triangle and then double it, and that'll be the area of the rhombus, right? So the area, actually, let me back up. Let's do a squared plus b squared equals c squared, right? So the important part here is across from the hypotenuse is the 5. Sorry, across from the right angle is the hypotenuse, which is 5. And then the other two pieces are going to be, say, 3 squared and h squared, right? So 3 squared gives us 9, plus h squared equals 25. Subtract 9 from both sides, and we get that h squared is 25 minus 9 is 16. That works out nice. Square root both sides, and we get that our h here, our height, is going to be 4. Okay, so that means the area of this whole triangle here is going to be 1/2 of the base, which is 6, times the height, which is 4. Okay, so the area of that is going to be half of 6 times 4 is 12. So that means that this is 12 and this is 12. So it means the total area is going to be 24 feet squared. This little apostrophe here stands for feet. So the whole thing is 24 feet squared, right? Which is basically just, the area is just going to be half of, it's actually going to be half of the base times height times 2. So really it's just this base times this height, right? Because we're going to end up doubling it anyway. Anyway, so the area of that rhombus is 24 square feet. Okay, I just moved our work from here over to here so that we can see our next piece of this here. So the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So it's basically the average of the two bases multiplied by the height. So in this case here, area is going to be 7 plus 11 divided by 2 multiplied by the height. So it's 7 plus 11 divided by 2 times 4. So 7 plus 11 is 18. 18 divided by 2 is 9. 9 times 4 is 36 square meters. So that would be the area of this trapezoid here. Okay? Okay. Okay, so we're going to use that info here to find the area of these trapezoids here. So we know that this is 2. That's 4. These are both 5. We got to figure out what this is down here because we know the area, area is going to be the base 1 plus base 2 divided by 2 times the height. Okay, so far we know parts of this. We know that we can call base 1 2. We got to figure out what base 2 is. And we know that the height here is 4. So we have to figure out what this is down here. Okay, so here's a nice part. Look, this is an isosceles trapezoid. We can figure out what this is right here by doing a squared plus b squared equals c squared, right? So here's our right angle. There's our 5. So the 5 is the c squared. So we can do, say, 4 squared plus x squared is 5 squared. 16 plus x squared equals 25. Subtract 16 from both sides. X squared is 9, which is nice. Square root of 9 is 3. So we know that this length right here is 3. Now we can also do this. We can draw this little straight supposed to be straight dotted line straight down there. So we know that this is 2. And then guess what? Here's another right triangle that has a hypotenuse of 5, and this height here is 4 as well. So that means, since we just did the math for that, this is also going to be 3. So 3 plus 2 plus 3, this entire length down here is going to be 8. So that second base here is now, going to be, we now know that that's going to be 8. Okay, so we get the area is going to be 2 plus 8 is 10, divided by 2 times 4, 5 times 4. Area of that thing is going to be 20 feet squared. Okay, let's do this one here, and then away we go. So 45, this is 4, this is 9. So we need to figure out what this height is right here. So if I'm going to take this, picture it, tip it over so that this is the bottom and this is the top. So the area is going to be, let's see, the 4 plus 9 divided by 2. Now we just got to figure out what this height right here is. That's going to be our height. Okay. Again, since this is a 45, this is a 45 also, so that makes this an isosceles, triangle. So if this right here is 4, that means from here down to here is also 4. If this whole thing is 9, that makes this 5, right? Since this is 5, and we know that these two sides across from these 45-degree angles have to be the same, that means that this height is also 5. So our height here is 5. So the area is going to equal 4 plus 9 is 13 divided by 2 times 5. So half of 13 is 6.5 times 5. So let's do that. We've got 6.5 times 5 gives us 32.5 feet squared. Okay? We got one last set of examples to do, but before we do that, let's do a little comedy break.
Those McDonald's fries are truly amazing, right? Has your mother ever made anything as good as a McDonald's fry? Not even close. We lie to ourselves when we eat McDonald's fries. We're like, oh, they're so thin, they couldn't be fattening. You ever eat too many McDonald's fries? Of course not! There's never enough of them. There's always that moment when you're eating McDonald's fries where you're like, what happened? Where'd they go? Then you start scrounging for the fry crumbs. You're like, oh, that's just a piece of paper from the straw. But it was touching the fries, so.
Okay, let's take a look at these last two here. Okay, find the area of the trapezoids. We've got 26, 14, and this here is 60 degrees. So we have to figure out what this is, and we have to figure out what the height is here. So let's figure out, let's draw ourselves a little line here, see if we can't figure out what this height right here is. Okay, so we know that this angle in here is 60, that's 90. I'm just going to redraw this out here just to give us a little bit better look at this. Okay, so we've got this is 60, and this is 14, and this is what we want to figure out. Okay, so honestly, probably our best bet on this, if you remember the 30, 60, 90 rule for triangles, that's great. Most people probably don't, so let's use our trig ratio, right? So SOHCAHTOA, right? So we've got, this is 60 degrees. This is the side that we want. That's opposite. This is the side that we know. That's hypotenuse. So opposite and hypotenuse is sine. So we'd want to do sine of 60 is going to equal our question mark, or x, over 14, right? Multiply both sides by 14. And this height right here is going to be 14 times sine of 60. Okay, so let's figure out what that is. 14 sine of 60 gives us 7 root 3, or 12.1, we're going to call that. So this is 12.1 for this height right here. So now we have one of the bases, we have the height, now we need this other base over here, right? So in order to figure that out, our best bet, since this is an isosceles trapezoid, that means this over here is also a 60 degree. This is going to be an identical triangle to this over here. So if we can figure out what this is, that's the same as that, and we subtract those two pieces from this to get this base over here. So now we're going to use this same triangle here. Instead of this being the question mark, this is going to be the piece that we're looking for. Okay, so now we have this from the 60, this is adjacent, and that's hypotenuse. So that's going to be now cosine. So cosine of 60 is the adjacent over 14, right? So multiply both sides by 14, and we get that this adjacent side right here is going to be 14 cosine 60. Okay, so now we do 14 cosine 60, and that happens to be exactly 7. So this right here is 7. That right there is going to be 7. So 26 minus 7 and 7 is 14. 7 plus 7 is 14. That's these two 7s here, right? There and there. So if we take 26 and minus the 14, that leaves us with 12. So this length right here is going to be 12. All right? So area of this whole trapezoid here is going to be, we add the two bases together, 12 plus 26 divided by 2, and then multiply it by the height, which is 12.1. Okay, so 26 and 12 is 38 divided by 2 times 12.1, and then half of 38 is, let's see, would be 19 times 12.1. So here's our 12 point, nope, that's our 12.1 there. So let's do 19 times 12.1, and that gives us 229.9. So the area of that whole trapezoid is 229.9 inches squared. Okay? Okay. I'm going to forego this last problem here just because we're running a little short on time, running a little long actually. So this is going to be the same thing here. You know what I'm going to actually do? I'm just going to actually go through and do an abbreviated version of this where I show all the work, and I'll just kind of walk you through it really quick. Okay? You know, actually this one's not too bad. So let's just do this. So I just dropped our height down here. This is going to be our height. This is what we got to figure out. This is 51, this is 12, and this is what we need. So from this angle, this is the opposite, and this is the hypotenuse. So we're going to want to do sine 51 equals opposite, which is our h over, because it's our height, over our 12, which is our hypotenuse. Okay, multiply both sides by 12. And we are going to do 12 sine of 51 to figure out what that height is. So 12 sine 51 gives us 9.3 for this height. Okay, so now we actually have everything that we need. This is actually a little bit easier than that problem over there. So our area is going to be the two bases, 21 plus 14 divided by 2 times the height, which we just figured out is 9.3. Okay, so we'll just do 21 plus 14 equals, divide by 2, and that gives us 17.5 times 9.3, right? So just take that answer, multiply it by 9.3, and there's our area, 162.75. And that is going to be meters squared. Okay? Okay, that's all we have for areas of rhombuses and trapezoids. If you have any further questions, please feel free to ask. Thanks.